Oh, you remember some of it. That's good. A function is a relationship where every x has only one y. And the way a function works, typical function, is like y equals 2x. Just a line. You give a function x, and it returns y. That's how they work. You throw it an x value, it gives you a y value. They probably use terms like independent and dependent variable with you at once upon a time. X is independent, y is dependent, because it depends upon the value of x. An inverse function is different. An inverse function is given y, and it returns the x value. Inverse more or less means opposite. You actually have used inverse functions in your life. Use them in geometry. No? Nothing? You did. Kind of theta, bro. So what is the sine of that angle? Theta. 4/12. I don't know why you're doing all that. You're reducing, okay. Sine of theta is an actual function. How do you find theta? What you told me is you told me the sine ratio of theta. How do you find theta? Huh?
Circle with the line.
Did you pay any attention last year?
Yeah, but I definitely don't know.
That's theta.
I remember hearing.
It's like a variable. Yeah, definitely did not.
It's like a zero line.
Last year was a blur to me. A lot happened last year.
So zero was kind of a curve for theta.
Oh, no.
Anyways, I don't have all that time here to talk about what theta is. It's a Greek letter. Really all the shopping. Anyways, the sine of theta was 1/3 after cosine reduced force. How do you find theta? The opposite. What's the opposite of sine function? Inverse.
Inverse.
Yes. You used the inverse last year. Sine the negative first power of theta. Oh, sorry, 1/3. This is how you found the angle. You used that last year in geometry. That little -1 right there is read inverse. This is read the inverse of sine, or sine. Actually pronounced arcsine. You used those last year. You used inverse functions. They're either entirely opposite. One of them says the sine of this angle is 1/3. So if we plug in the angle, it would spit back 1/3. The other one takes the 1/3 as the argument and spits back the angle. They're inverse functions of each other. They do the opposite thing. So you have used them last year. The goal of today is to write the inverses. There's a lot more in this section. This is actually the full lesson. We actually learn how to write inverses. But here's how you find the inverse of a function. It's really, really, really simple. Since the idea of inverse is that x and y exchange values, that is how we start. After we exchange x and y, we resolve it for y. There's actually a little bit more to that, which needs to be added in. When finished, place y with f to the -1 x. F to the -1 of x is read inverse of f of x. Remember, inverses swap around x and y values. That's all they do. What you got, Sean? You can move wherever you want, man. I'm trying to get Grant to move to the front room all year. He just don't want to do it.
I'm losing.
I'm sure you will. Anyways, this is how you write all inverses. You swap x and y and you resolve for y. We have a nice, easy example here. Yeah, you did that on quiz. I usually do that around chapter 2. You guys did chapter 2. All right, so that might be one of the reasons you haven't seen it. I've been doing this so long, everything blurs together. So I'm going to swap x and y. What's that y going to become? X. It just becomes x. That's all it becomes is x. Equals -3. There's an x. What's it become? Y. That's 1. And then you resolve for y. Now we don't write f of x in here because I just make it look up here. I'll use x and 1. So what are you going to do? Subtract 1. The next thing coming up. Divide by -2. I'm actually going to divide those pieces by the negative. You have a negative x over 3. You can write that as -1/3 if that's what you like. I don't care. Read that plus 1/3. Now, you're never going to see on your EOC or ACT stuff where they say that's the inverse because it's not telling you it's the inverse. It just says y. You need to state it's the inverse. That's where that notation comes in. Replace y with what? F to the -1 of x, which is just a fancy way of saying inverse. Is -x over 3 plus 1/3. And it would be nice if writing all inverses was that easy, but it's not. You know, that was just an easy one. Now that was there to teach you the concept. What do? Swap x and y and then resolve for y. That's it. Of course, they get harder and harder to do. We will jump around your notes and try and focus on that part first. Come back and do some other stuff. So I'm jumping like way towards the end on page 10. That would be on the last page, I think. Find the inverse of x minus 2 to the 5th plus 8. That's got f of x there, which is y. You've got to understand that. That is just y. Now just follow the steps. What do you do with x and y? So that y becomes x, and that x becomes y. And do a resolve. Trey, what's the first thing you'd like to do? Distribute what? No, I want to hear what Trey is saying, so I can correct it.
Yeah, I don't know.
Oh, you want to do something with that 5?
Yeah, that's right.
You realize to do x, y minus 2 to the 5th, you'd have to write it how many times? 5 times. You can't move the exponent in. It's not y2. It's y minus 2. If there's plus or minus, you cannot move the exponent in case. There is no rule for that. If you memorize your rules, you know that. There's no rule for that. You write it 5 times. That's the deal. So no, that's a lot of work. Avoid that. Also, what you have to do? Subtract 8. Easy stuff first, kids. Why you guys want to handle the hardest thing you see first is beyond me. It doesn't even work that way. It doesn't. I can't change the brakes on the car without taking the tire off. Can you? No. So why do you even try to do it first? You know that. Isolation. Now, we need to free up that y. There's only one thing left. There's actually 2 steps we have to counteract, but we need to counteract that 5th power. How do you counteract that 5th power? The 1/5 power. The reciprocal power. So both sides get raised to the 1/5 power because that is the opposite of the 5th power. Got to wrap that side. I'm going to show the exponent because you need to understand why you're using it. You multiply that 5 and that 1/5 together, what do you get? It cancels out. You get the first power, right? Anything to the first power is 7. Last step. Add 2. Are you going to add it inside? No. The thing's in prison. Maybe add it outside. Go ahead and replace that y. F to the negative first. Red inverse of f of x. That's not so bad. I don't know if I want to do the word problem or not. There's a lot of stuff to talk about here. Yeah, we're going to skip the word problem. Jump to the next one. The inverse of a fraction or rational expression. Of course, this will be the one you guys ask me about tomorrow. It will be. You can't help it, but that'll be the one you ask me about. This is how they work. And you'll ask me about it, and I'll start going, and I'll see everybody writing down, like, you won't even do the first step. What's that f of x supposed to become? It's supposed to be a y, and what will that y become? X. And that's the first step. What's that x and x plus 3 become?
Y plus 3.
Yeah, it's a y plus 3. But you'll see kids, they just start writing down like they didn't know what they're supposed to do. That's the first step, and it's ridiculously easy. Now, all rational expressions, what we're going to do is we're going to do a process called cross multiplication. Or you can multiply both sides by the denominator, it doesn't matter. Those pieces get linked together. Those pieces get linked together. I always do the top and the bottom first. What's x times 4y? 4xy. What's x times a negative 5? It's 5x. And the right side is 1 times y plus 3, which is y plus 3. I'm going to give you about a minute to see if you can figure out what you're supposed to do. Anybody got an idea how you're going to solve that thing for y? You're going to subtract the 3. Wrong. There's still a y on the left, bro.
I know your Y now.
Then it would be in the bottom. Go back to your beginnings of solving. You're solving for x. You put x's on one side, numbers on the other, didn't you? put y's on one side, everything else on the other. Does 4xy have a y?
Yes.
Leave it where it's at.
So you subtract the,
Y has a y, move it to the left. You want your y's on one side and everything else on the other. 5x doesn't have a y, move it to the right. Cross the equal sign, change your sign. That's how it's always worked. You want to solve for a variable that goes on one side, all the rest of the crap goes on the other. Isn't that how it works? Why would you change that? That's commandment number 1. Pull it. What can you pull on the left-hand side?
Y.
Pull it. The reason that's the first commandment. You pull a y from 4xy, what's left? 4x. Pull a y from negative y, what's left? How do you solve for y? Divide. You have y times crap. That's what you have. You divide out that 4x minus 1. Now what are we going to replace that y with? 1. All the rational expressions, they follow the same process. Cross multiply. Everything with a y on one side, everything else on the other. Factor, divide. Every single one of them. Has it been resolved for y? And yeah, that's your final answer. I'm going to go back and do a graphing problem. It's early on in your notes. Graph 2x minus 3y equals 6, its inverse, and the line of symmetry y equals x. Well, let's start graphing. It says graph 2x minus 3y equals 6. What form do you want that thing in? I put it in y equals mx plus b. That's me, though. So where's 2x go? 6. Negative 3y equals negative 2x plus a 6. Divided by negative 3. Where's that thing cross the y-axis? Negative 2. And from negative 2, what do? Up 2 over 3. Pretty close. We do the other easy part. It says, and the line of symmetry y equals x. Where's that thing cross? 0, origin. And slope is rise 1 minimum. And dash here. Well, symmetry is a hard concept for some kids. Where's symmetry on the human body? Where's symmetry on the human body? Right between your eyes, straight down. Now we're going to write its inverse. To write an inverse, what do you exchange? X and Y. It's probably easier to do it up here than down there. So let me go back to the original and do it. That 2x will become a 2y. That 3y becomes a 3x. So 6. So we're going to add 3x and then divide by 1. 2. 3 halves x plus 3. I added, divided. That thing's going to cross at 3, and it will rise 3 and run 2. Or fall 3 and run 2. You should meet up at that line of symmetry. red, blue, nice orange. Lines of symmetry I know are kind of hard to deal with, but they're the line that you can hot dog over. The distance from here to here is the same as the distance from here to there. It's like the distance from here to here, same as the distance from here to there. That's the line of symmetry. You got 5 in this line.
What's the point where they all move columns?
Nothing.
Special name?
Nothing, because not everything intersects. It doesn't have a special name that I'm aware of. Oh, you might look it up. There might be a name for it.
Red mosquito door.
Oh, that doesn't mean it doesn't exist. And there's a whole lot more out there that I know than I do. My major is computer science, not math. I just happen to be good at math. All right, let's do this, and then we'll probably continue the rest of this on tomorrow. Prove two functions are inverses. You're going to love this notation. Two functions are inverses if f of x is equal to. That is not correct. There's a typo in there. Two functions are inverses if f of negative x, inverse of x is equal to x, and f of the inverse of f of x equals x. Now that's some funky function notation.
What's the second one?
The inverse composed of f of x. Two functions are inverses if f of the inverse of x equals x, and the inverse of f of x is x. Or do you want me to just actually read it? Or the functions are symmetrical with line y equals x. Yeah, it does. Let's do with the remainder of class we have in time to verify it with the easy part. Tomorrow we'll do the actual algebra. Now I'm not going to graph this by hand. Go to y equals. I'm actually going to type the functions in one at a time so you can see them if you're not playing along. There's 3x minus 5, standard zoom. Then I'm going to graph the line of symmetry. Y equals x. And it won't dash it for you. Now, see how the first one was? There's your line of symmetry. The next one's going to come in from the right and go above as it goes back. And the inverse, 1/3 x, it's probably what, plus f5 instead of minus f5, or a fraction, 5/3.
Oh, 1, 2, you said that.
Yeah, because that's the line of symmetry. Now, I think you can tell by looking at your TI-84 that if you pick any point, you have your kind of equal distance, don't you? So yeah, they are inverses just by looking at the graphs.
I can have
first of which, right? Or here? No, no.
Yes, the calculator has that ability. I'm well aware, Sean. There's a reason I don't talk about it. The reason I don't talk about it is because the inverses on your EOC are in the non-calculator part. Remember, Sean, you're smart. Maybe even smarter than me, but I know more.
No, I didn't use a button on there.
It's there. It is there. You can just type in the function and press that inverse button. No, that doesn't work. Nope. It's right there under math. That means inverse of x. Anyways, we'll continue here tomorrow. You can go ahead and start on your homework. I'll probably ask if you have any questions on it first thing tomorrow. There is some of that stuff you can do.
Yeah, first, like, I don't know, 10 questions we talked about.
There are several of them you can do.
Here, Mr. Milbrath.
See you, Sean.